So in this video segment, we're going to learn how to use Python and SQLite library to create and delete a table. Here's the code that will perform such a function. And before I start describing what it's trying to do, let me also bring up this file here. Okay, so this is our familiar my familiar temp/pyon, where we have previously created test database abc.db and then this prepared database basic.db. So this is what it is. What we're going to do here is to programmatically create a new database. All right, we're going to create a new database, and we are going to also create a table, and we are going to insert a couple of values and all that. So this is how the code looks like. Notice that this account database is not there. It's not there. It's completely absent. Right? So we're going to connect to account.db. Normally, if we try to do that, we try to open a file for read and the file is not there, we'll end up in error. But that's not how SQLite looks at its so-called database file. It will create an illusion that it has been created, because if it's not there, it will create this database. So then we'll see this icon, a new icon called account.db being opened up. So what we're going to do is we're going to, after that, create a table using SQL command. So you see that I follow the standard 4-color block. Orange to open up and import the library, establish a connection to the intended database, right? So that's standard. And towards the end, we close the connection. And as a good practice, we also close the cursor. This closing of the cursor sometimes has certain useful help, in the sense that we are able to track which cursor has been closed and which not. It's just a good practice, keep it there. But if you forgot to close cursor, or for quick and dirty hacking, right, you might just close connection, and that would close off any cursors that are attached to the connection. So after the yellow block, we have green, cyan, green, cyan. Here we have a couple of greens. Reason is that we take the cursor, and we will create a command here like this. We can create a table, but this is just a string, and we're just using it for illustration. We just talk about it, and we didn't actually execute the string command, nor did we execute script. There's a difference here. I put in comments just so that when you try to review, it's easier. This execute assumes that the text string, no matter how many physical lines there are, is one SQL command, and you will do only one SQL command. And the execute script, on the other hand, will be able to deal with one or more SQL commands separated by semicolon. So for me, my preference is just use execute script, unless there's strong reason why you must ensure that only one command is performed, right? So for me, since I'm programming the SQL command, I know what I'm trying to do. So for simplicity, I just always run execute script. So here, I'm going to just immediately override SQL command, right? And put in what we have been preaching about, to make sure that we are not having the table when we are trying to create it afresh. So I'm going to delete away any pre-existing table. The database is there, but if there's any already created table, why? Because we're going to run this a couple of times, and the first time, there's no table, so it's going to fail the drop table. But I said if exists, so there's no failure, right? So it continues quietly, and it's going to create with it using this schema of 4 columns. And I think the data type is pretty standard, just text. And I'm using account code, which is going to be, remember, code is a good source for primary key. So they are distinct, but they are all in strings. So alpha numeric characters are allowed. And so I store it in text. It doesn't have to be always integer for primary key. So this is fine. And I call this primary key. What is primary key? Remember, it has to be unique across the database, right? So here, What else do we have here? Yeah, then we now actually execute script, execute this multi-line string. Okay. Now notice that I didn't really perform a commit, not yet at least, because I have more changes. So remember, creating, deleting, drop table if exists. That's a big thing. You're dropping, you're deleting the whole table, right? And creating a table is a new thing also. So those are big changes. But even though we have executed the script, execute script here, we have sent the command across, what SQLite will do, in fact, all SQL servers will do, is that whatever you do later on, it's going to pretend as if the previous commands have successfully executed, but didn't commit to the database. Now, this one is a bit confusing, I understand. So the idea is um, SQL is going to provide an illusion to the subsequent commands. For example, insert into this table called account. Now, if you didn't create the account, this insert will fail, isn't it? But SQL will say, I pretend as if account has been created, when actually the real database didn't yet have this table committed yet. So it's going to create an illusion. If you had an account table looking with like this schema here, then I see. Then when you insert into accounts for values or text, yeah, I think I can do that. It will pretend somehow to insert all the text values into this virtual illusion, but actual database not committed, still original, still nothing yet, right? Why is this behavior necessary? Because it's actually quite a big overhead to pretend this. The idea is that sometimes when we insert data, it's not like this case where we have combed through all the lines, all the data are there, and we know we definitely want it. It's not, you don't have full view of all the data. So you don't have good control over everything yet. What happens if each line is interactively received from user by asking, what is your account code? You know, which part of the account do we store in? Balance sheet or profit and loss? What do you describe? What's the description of this account? So we ask user to enter all these interactively. And at some point, user says, oh, I entered wrongly. Oh, can I escape? I don't want everything. So if you have that, then you're in trouble because if every line that the user types is already committed to the database, you cannot undo very nicely, especially if some of these data also affects other pre-existing tables or change some of the data. You're really in a difficult position. Yeah. Fortunately, before you do any committing, if you don't commit, that is, if you don't commit, you can still do a rollback. You can sort of say con dot rollback, and it will roll back to as if you have never performed these modifications. Kind of neat. It's like a quick undo, like erase everything, press escape to, you know, come out and not change everything, which is nice because you might have data integrity issues if you modify some and not modify the rest, and you might have difficulty to undo all the changes if you didn't have this commit facility. Okay, now can I just ignore committing and close it by basically just execute many whoops error and I don't commit and then I close? Not very good, not very good, because um, most of the times we actually forgot to commit what we want. So SQLite and some SQL servers will kind of be nice, and if you should forget to commit, upon closing, it will commit everything. Right? The reason of having an explicit commit is that after committing, you can also select back and read back. So that is the part that's going to tell the difference. If you don't commit and you read back nothing. The table is not there, something like that. So if you commit and you read back, commit and you read back, then you can check and write and read and check back. But if you just omitted the commit, then towards the end, when you do a close, when you actually want to undo, you might be surprised that it does a auto commit for you for certain cases. So all these are documented in SQLite manual. So it's a bit like, wow, you mean I have to memorize all the situations, right? So it's much better to be explicit. Do you want to commit or you want to roll back? Don't depend on default behavior. Okay, so let's move on. We have talked about the execute and execute script, and I'm just sticking on to execute script for reasons I've explained. And we're going to insert a bunch of data using insert into. We all know that. But here comes a little bit of a programmatic interface differences. Here, the encouraged way to do insertion of data is not to put all the strings inside and make it a one big string inclusive of the insert command and the data themselves. Okay, let me say again. The way to do it is not to embed equipment and be equip and BS and asset into the question marks and do it as one big string and then say execute script. That is not the right way. Why? Because Python, as you know, the values can have different types, data types. It is good to let the interface function, here in this case the execute many, the interface function to see the actual data type. If you force convert all the values like 1, 2, 3, is an integer type, you force convert into a string and put it inside the string, the cursor interface will have no way to tell whether the 1, 2, 3 was originally coming from integer or actually just a string, because that information has been lost. Second thing is, of course, as is written in many documentation and advice, is that this way it's less susceptible to hacking. So sometimes it's possible to insert unwanted stuff like wrong data, incorrect user account, hijacking the password, set the password to null, or insert very, very mischievous, long, super long string just to crash your database or whatever it is. So by and large, just stick with this way to insert data, even for one row, But here I show you how we can very conveniently basically just record all the data we like to store in a very compact way. So it's a list of lists, but we are using tuple just to distinguish the inner list from the outer list. So it's a list of lists where the inner list is one row per one one tuple per row. One tuple per row. Now remember that this is how we created our data frame as well, isn't it? That's one tuple per column. No, per row as well. So it's a list of lists. So it matches the same programmatic thinking between pandas data frames and SQL.